Hello everyone, welcome back to my channel Programming with a Purpose. This is the lesson 10 in the series of learning Swift for iOS development. So here I'm going to discuss initialization in classes, structs and enums in detail. So it is a process that is used to prepare instance of class, struct or enum to use it for our further purposes. So here we are creating a class with the name person. We have created a property variable name with type string, and after that we have created an initializer, and the default word for it is init, which is a keyword. After that, rounded brackets and a curly brackets, and the name is set to Umar. On line number 13 we are creating the instance of the person with the name P, and after that we are printing the name of the person using p.name. You will be able to understand it if you have followed the previous tutorials that I have discussed. I am going to quickly go through some of the things that I've already discussed on those lectures, and then we are going to move to advanced concepts for initialization. So here, default property values, I am copying the class person and I'm going to modify it. Here I'm setting the variable name as Umar. So this basically initializes a default init method without explicitly writing it. So on line number 26, I have copied the class person, modified it into a struct, and here I am going to discuss the initializer parameters that can be passed to an init method. So here you can see that I am passing the parameters name string and age int, and here I'll be initializing them inside the init method. So here I'm specifying self.name and self.age. So here I have set these values, and after that we are going to pass these values using the init method on line number 37, and we are going to modify our print statement, which is going to print these values. You can see here there's a small error that age is not a variable, so we have to basically use the instance.age. After that we are going to move on to creating another instance with different properties. So here I am going to show you how you can avoid writing the parameter name inside a function call and specifically initializer call. So when you are defining a function, you need to basically pass the parameter with an underscore space. After that there is no need to add that parameter name when calling that function. So here you can see that underscore name and underscore age has helped us to basically just specify the values that we want to pass to the person struct. So this is all for the initializer parameters. Here I am copying the struct again, and I am commenting out the previous code so that there is no clash in the struct, that the two structs are created with the same name. So here I am going to basically write a function print name where I am going to print the name. And as you can see that I have mentioned the variable age as an optional here. So when you are creating an instance, you are going to basically use the init method, and we are going to modify the init method as well, that we do not need to specify the age even if it's not defined with the default value, because default value is set as null. So here I'm just specifying the name, okay, and the init method can be called here, and I'm going to print the name. So Sidra person is passed and the name is printed. So you do not need to specify default value or a default init method for age. You just need to add a specific value for it. So here I'm going to show you. As I'm trying to basically change the age, it is going to give me an error because the object created is with the let name of person, which is basically a constant. So you need to specify it as where to change the value of its member. Now again I'm copying the struct person, and we are going to see another feature. So basically I am here specifying one of the property as let, which is a constant, and basically the init method helps you to set it once, but if you are going to set it again, it is going to give you an error. I am going to show you here. So here I am changing the name Sidra Heather, and here you can see that it is giving me the error that change let to where to make it mutable. It's immutable. So up till this point we have discussed let and where effect on the instance as well as on the property inside a class. So I hope it is clear up to this point. You can only specify let when you are sure that the value is not going to be changed once it's set. In that case, you can use let, otherwise you need to specify the properties with the keyword var. So here we are again copying the struct person, and we have made the variable name from let to var. After that, I'm going to show you MemeberWise initializer, which are basically a property or a feature of structs. You cannot use this for classes. Here you are going to basically see that a default constructor is shown, a default init method with name and age. So here I'm passing this value, and I'm going to now call the function print.name, and it is going to print the name Sidra. Now you can also create this init method with simply the name, and it is going to create an error because the age is not specified here. The age is not set here. So we are going to basically set a default age and a default name. So here Sidra is printed. You can also create an instance with the initializer with the parameter age. So you can see here that no init method is specified, but we can still create the initializer with our specific parameters that we want to pass to the object. Now here we are going to discuss initializer delegation, which means that using initializer in other initializers so that to avoid the duplication of code. So here I'm going to show you an example of it, and it's different for value type struct, enums and classes, for which are basically reference types. We are going to discuss reference types in a few moments, but here we are going to discuss struct from this angle, that how initializer delegation works inside a struct. And it is pretty much similar with enum, and it's quite simple and straightforward. For classes it is a bit complex. So here I've copied the struct person again, and I'm going to basically uncomment the init method, and I'm removed the age. Here you can see that I have set a default initializer with nothing inside the body, and after that I am declaring another initializer with the name and age parameter, and I'm going to set both of these values inside this initializer. So here I have set a constant name with the parameter name and self dot initializer is called with name. And here I am going to basically set the age. Here you can see an error will occur. Why this error will occur is basically you are going to see here self used before self.init call or assignment to self. So it means that self is not created on line number 118 where we are accessing it. It will be called after the line number 118 is executed. So we are going to basically add it after that line, and here I am printing the person in the function print person. So next we are going to create the instance of this struct, and we are going to call the function or the method. So person dot print person is called, and it is going to print because the string is specified as nothing. So I am dash with age 5. Here I am specifying another instance with a name and age. So here there are different init method that are called. Person1 dot print person is basically I'm Sidra Ahmed with age 10. So both of these initializers can be called, and you can see that what is the effect of calling the default initializer and the initializer with parameters. After that we are going to discuss class inheritance and init methods, which consist of designated init methods and convenience init methods. So let's see both of these things in detail in theory. So here you can see that designated initializers are basically primary initializers. It initializes all the properties of the current class it belongs to and calls initializer from the superclass up the chain. Each class should have one designated initializer. So here is the syntax of a designated initializer. The simple init method is the designated initializer. So convenience is a secondary initializer and usually optional. To call a designated init method from the same class with some parameters, that are set to default values and rest can be changed. It is usually created for an instance of a class for a specific use case or a value type, and this is the syntax with the name keyword convenience. So here you can see that in this picture there is a relationship of superclass and subclass. Each of the designated initializer calls the designated initializer of the top or superclass, and each of the convenience initializer either calls a designated initializer of the same class or the convenience initializer of the same class. Here it is a more detailed picture, and you can see that designated calls another, a designated convenience either calls another convenience or a designated initializer of the same class. And each of the designated initializer of the same class are independent, and both of these call the designated initializer of the superclass. So here are the 4 different cases of the relationship. So now I'm going to discuss the 2 phases of initialization process for a single instance of a class. So here you can see that in phase number 1 we are going to basically initialize all the stored properties of the class. So each of the stored property will be assigned an initial values by the class it belongs to. And in phase number 2, each class can further customize its stored properties before the instance is ready to be used. So it means that it can act as a default init method in phase 1 and a specific init method in phase number 2, where we can specify and give custom values to each of our variable or basically the property of a class. So these are the 2 phases initialization. Here I am going to discuss each of the phase in detail. In phase number 1, a designated or a convenience initializer is called on a class. After that, a memory for a new instance of that class is allocated, but the memory is still not initialized. Okay. So we are going to now populate the memory. A designated initializer for that class confirms that all the stored properties introduced by that class now have a value. And once we determine the value and the type, after that the stored properties are now initialized. The memory is assigned to them. The designated initializer hands off to superclass initializer to perform the same task for its own properties inside the superclass. What we have seen in basically pictorial form in the previous slides. Now as a step number 5, you are going to see that once the superclass and basically subclass are initialized, this process continues up the class inheritance chain until the top of the chain is reached. So each of the superclass will basically initialize its own variables. And after that, point number 6 is once the top of the chain is reached, the final class in the chain has ensured that all of its stored properties have a value. The instance memory is considered to be fully initialized. So it means that each delegates up and its remaining members are initialized. And in phase number 1, all of the memories are initialized. After that, we are going to work back down from the top of the chain. Each designated initializer in the chain has the option to customize the instance further. Okay, this is the same as phase 2 we have discussed. Initializers are now able to access self and can modify its properties, call its init instance methods, and so on. So how we are going to customize these values? They are able to access self and modify its properties and call its instance methods. And on point number 2, finally, any convenience initializers in the chain have the option to customize the instance and work with self. So here basically on phase number 2 comes the convenience initializer, which can basically help to assign the value. So here we are going to see some of the concepts in action. So we are going to declare a class vehicle. So here we have created a property with number of wheels as 0 and a variable description, which is basically a string. So this variable description is a computed property, and we are going to use basically number of wheels to return from it with the string wheels appended to it. So it does not have any initializer. It means that there will be a default initializer with the values that are already set to 0 and a description that is set to number of wheels appended with the wheel string. So here we are going to call its instance. So let vehicle is equals to vehicle, and after that we are going to basically print the description. So here we are using the instance name vehicle dot description is printed. So you can see that vehicle 0 wheels is printed. So it means that a default initializer is at play here. After that, we are creating a subclass to this class with the name of bicycle. and it is going to extend our class vehicle. Here we are writing its init method. So what we are going to do it here, we are going to call the super.init method, which is going to initialize all of these variables, and after that we are going to set number of wheels to 2. So here you can see that I have basically overridden the designated initializer, and I'm going to call super.init, and if I am going to comment out the super.init, it is going to give me an error because number of wheels is nothing inside class bicycle. So if you need to customize it, you need to call super.init method. So here I'm creating an instance of bicycle with the name bicycle, and we are going to print bicycle.description here, and it is going to give me bicycle as 2 wheels. So it means that it is overridden. So this is how that the designated initializer in our class bicycle has called the designated initializer of our super class, which is vehicle. So here you can see that I am basically stating another thing is no need for init if no customization for super class is required. It means that if we do not need to set number of wheels to 2, we can omit this override init method. But if superclass init method is asynchronous, which means that it is going to basically getting something from the server or performing an async operation, that we need to write await super.init, because otherwise we will not be able to access its properties. So in our case it is synchronous, so we can basically omit it, and here you can see that I have commented out and still it is going to give me a default value which is 0 wheels. So this is basically why we are going to use super.init only in that case if we need to customize the parent class. So here we are creating another class hoverboard, which is extending the class superclass vehicle, and here we are specifying a color with the type string and an init method which is going to basically set the color, and then we are going to override the property which is a computed one with the name of description, and we are returning super.description. So it means that the wheels are appended in a beautiful, and we are going to add the color to it. So here you can see that we have just specified a single initializer, which is a designated initializer in the class hoverboard, and once we are going to call it with the designated initializer with the color gray, and after that we are going to print hoverboard and the hb.description. And here you can see that it is printing 0 wheels in a beautiful gray. So the default value of wheels is picked, and the description, computer description, is basically picked from there. And here you can see that if I specify here self.init method, what is going to happen here? Sorry, super.init. So here you can see that self.color is not initialized at super.init call. So we have to specify after that this, and the same result. It means that super.init has no role in this class, so we do not need to specify it here, because we are basically changing the property of the same class and not of the super class. Now next move to another concept, which is automatic initializer inheritance. So it basically shows that how we can inherit an initializer from a super class. Subclasses do not inherit their super classes init methods by default, but in some conditions that do happen. In both of these cases, point number 1 is if a subclass does not define a designated initializer, it inherits all of the designated initializers of the superclass, which we have seen in the previous example. If a subclass provide implementation or override all of the designated initializers of the superclass by providing custom implementation or by inheriting using the point number 1, then it inherits all of its superclass convenience initializers too. So it has already inherited and overridden the designated ones, and basically in addition to that we are going to get the convenience initializer as well. And in point number 1 we have seen that if it does not specify designated initializer, it is going to inherit all of the designated initializers of the superclass. So here we are creating a class with the name food, and we are going to basically create a variable name which is of type string. So here you can see that I created a designated initializer with the parameter name string, and here the self.name is set. After that I have set a convenience initializer, which is basically initializing using the designated initializer, which is self.init with the name unnamed. So this is the relationship that you are going to see. There is a convenience initializer which is calling a designated initializer in our class, and since it is a single class, so it is our base class. So here you can see that the convenience init initializer is calling our designated initializer with the parameter name. After that, we are going to create an instance of our class food, and here you can see that I have set the named pasta is equals to food, which is with the name pasta. So here you can see that if you are going to play the code, the named pasta instance is set with the name pasta. So it means that the designated initializer is called. So next we are going to create another object by using our convenience initializer, which is basically simply using the rounded brackets, and as you can see that we are going to see the name as unnamed. So here we have called the convenience initializer for the case where no name is provided for our food item. So next we are going to create another class that is subclass of our class food, and here we are going to basically specify a property variable quantity with the type int, and after that we are specifying an init method, which is the designated init method, which is setting the name string and quantity int. So it is going to set the quantity, and after that it is going to call super.init method, which is going to call the designated method of our super class food, and after that we are overriding our convenience init method, where we are going to provide the name, and after that we are going to set the quantity to 1. So these are the two cases where we have basically created a designated init method and overridden a convenience init method for our class recipe ingredient. And how its relationship will look like, I am going to show you here. So this is the previous setup. Now we have added another class, and as you can see that the init method of the convenience is inherited in our subclass, and after that the convenience init method is called, which we have basically overridden, and after that the designated init method is created with the parameter name and quantity, which is going to call the designated method of our class food, which is a super class. So this is the relationship between these classes. Now we are going to create the instance of our recipe ingredient. First of all, we are going to basically use a simple basically default initializer, and then we are going to create an instance too, which is using the recipe ingredient using our name, which is our convenience initializer with the name pasta, and after that we are going to call the instance 3 with a designated initializer name eggs. So the first instance is going to call the initializer of our super class, the second one is going to call the convenience initializer, which is overridden, and the third is basically the designated initializer of our class recipe ingredient. So this is how we can create the different instances and how it is going to return us different results. After that we are going to create another class with the name of shopping list item, which is going to extend our class recipe ingredient. So recipe ingredient is now a super class of shopping list item. We have added another property to it, which is purchased, and it is always set to false, and then we have created a computed property with the name of description of type string, and it is using our variable output. So here it is going to append it quantity cross name, and after that it is going to basically update the output and append a yes or no with each of the quantity here and the name of the property. So here if it purchases yes, a yes is printed, otherwise a no is printed, and the output is returned for our description to be set. Here is the pictorial form. This is the previous picture that we have already discussed with the relationship between food and recipe ingredient, and here you can see that another class is added. So you can see that the inherited init method on the shopping list item is going to be inherited from recipe ingredient, which is inherited from the convenience method of the class food, and inherited method of the init name is inherited from our convenience init method, because the designated method is inherited from our recipe ingredient. So all of the methods inside the class shopping list item are inherited. and the rest of the structure is pretty much the same, but only a quantity is added inside our inherited method inside the shopping list item with quantity. Rest of the methods are pretty much same. So you can basically understand that each of the convenience method is calling another convenience method, and only one of the convenience method is then finally calling the designated method, and designated method, even if it's inherited, it is going to call the designated method of the superclass. So basically calls for the convenience methods move across the class, and the designated methods basically funnel up the data across the basically hierarchy of classes. So basically it is going to call the designated methods of the superclass which we have already established. So here I am creating an instance of our shopping list item with the name of breakfast list. So the first item is basically shopping list item, which is an inherited convenience method. After that, the inherited convenience method, which is overridden with the parameter name pasta, is called, and the third element is the shopping list item with the name egg and quantity 6, which is basically our designated initializer. So we are going to change the name of our 0th element, which is basically a convenience method, and named as unnamed, which is set to fresh juice, and after that we have set its purchase to true, and we are then iterating over the list and printing each of the item. And as you can see that there is a little bit of space issue, so we have set it, and after that you can see that the list is printed. So this is how the designated and convenience methods inside the classes that are inherited will work. So after that we are going to move to deinitializers. I hope you have learned something from this series, and if there is any confusion, post in the comment section. Do not forget to like and share this video, subscribe to this channel, and thanks for watching.